Next speaker is Patrick from the Netherlands. He's Oracle Ace Director. Thanks a lot, Patrick, for your time.
You're welcome.
So you can start.
Okay, thanks. Yeah, like I mentioned earlier to Marcel, this is a presentation which normally takes about 45 minutes. So we're going to have to rush get to the end in 30 minutes. If we don't make it, I'll provide a PDF of the presentation so you can check out the rest of the work. If you have any questions, put them in the chat and Marcel will interrupt me if it's really necessary to get the questions answered. So I'm hoping this thing works. Does this selection work? Doesn't this work? Yeah. A little bit about me. I'm Patrick Barel. I've been working with Oracle since '97. I've been doing PL/SQL since '99, and I've been doing that ever since. I became an Oracle Ace in 2011, became an Oracle Ace Director in 2019. I do a lot of talking all around the world. At the moment, it's all around my attic. I blog sometimes. I've written some articles, but the site doesn't exist anymore, so you can find the articles on this link. And I've also had my own column in the OTech magazine, and it doesn't exist anymore. The site doesn't even exist anymore. So I've put my articles up on my own website. These are my contact details. Like I said, I'll provide a PDF, so you'll get the contact details there. I'm an Oracle Ace Director. If you want to know more about the ACE program, go to the bit.ly link here on the ACE program. And if you want to nominate yourself or someone you know, don't nominate yourself. I wouldn't do that. Go to acenomination.oracle.com. There is, as you all know, probably the always free tier, 2 cloud databases for free forever. And all you have to do is log in every week or so. And that'll give you access to the latest and greatest databases. That's where I learned to play with Oracle 21 just recently. Topic of today, a collection's a collection no matter how small. I came up with the title because I was watching an animation movie, Horton Hears a Who, and one of the things he says, a person's a person no matter how small. And I figured that was a nice title for a presentation, and then what will you do with that? I just had the title. I had to come up with some nice presentation stuff. So I thought, well, let's take a trip down memory lane. I've been working with Oracle since '97. Oracle actually exists since 1977. So it took them about 15 years to get to Oracle 7. And what was great about Oracle 7? Oracle 7 was not just a SQL in the database. They also implemented PL/SQL. And with PL/SQL, you got the access to a lot of variables, control loops, etc. But not just scalar variables, they also gave us collections. Back then, it was only what they called PL/SQL table, because it was like a table, but in memory and in PL/SQL. They were single dimensioned, unbounded, well, only bounded by the memory you had. It was a sparse collection, so the items didn't have to be next to each other, and they have to be homogeneous elements. So all the elements in the collection are of the same type. So it's a collection of numbers, a collection of varchars, a collection of scalars, anything you can think of. But you can also create a collection of records. That's the only way you can mix and match different scalar data types in the same collection. You cannot mix numbers and varchars, but you can mix or you can create a collection of records where you have the numbers and the varchars in them. How do you create one of these PL/SQL tables? They were called PL/SQL tables, hence the extension PT. You make a type, give it a name, in this case, name's PT, and it is a table of varchar 230. Index by binary integer, that was the keyword telling it it was a PL/SQL table. Then you create a variable based on the new type, and then you just fill it up. You fill it up any way you want to. Just put something in position 1, put something in position 42, put something in position 10. As you can see, the collection retains its ordering. The indexes are going to be ordered. So 1 and then 10 and then 42. There are also a couple of methods defined on the collection where you can ask how many items are there in there. So if we say lnames.count, it gives us the number 3, because at this point there are 3 elements defined in the collection. And then we add one more. So the new item gets implemented at number 4. The indexes, oh, I didn't want that to move. The indexes don't have to be positive. They can have negative numbers as well. So there's 2 to the 31st minus 1 to 2, now 2 to the minus 31st plus 1 and to 2 to the 31st minus 1. That's a lot of index possibilities. And after you've created your collection, you use the a while loop where you can go to the first item in your collection using the first method, get its index, and while the index is not null, so at the end we'll go to the next one, and then the index will become nil. While it's not nil, we can loop through the index. So go to first, then go to next, which is 1, then go to next, which is 4, and so it jumps over all the empty spaces. Creating a collection like this is a lot of work. You have to type a lot of things while the data is already existing in the table. So you can also create a collection based on data in your table. I've created a couple of tables, relation types, and the NetMcDot. NetMcDot is the mayor of Whoville. Check out the movie. It's really brilliant, especially with kids. And I've put in a couple of rows in there. And then after that, I can create a cursor for the names, selecting the first name from the table, and just get the first names where the type is, I think 18 was daughter or relative. And then we create the PL/SQL table again, based on varchar 230, index by binary integer. That's just the syntax. And then we can fill up the collection by selecting from the table. We open the cursor and we loop until we don't find anything else in the cursor anymore. And we fetch the cursor into the collection using the collection count +1 to always get the next item. And then after that, we can just go from first to last because it's densely filled. We will fill up items from 1, 2, 3, etc. So in that case, we can use a for loop with the first to last to go through this collection. You can also use collections as parameters, so you don't have to send in all or a lot of different scalar variables, parameters to the different programs, or you can you can use the collections instead of putting it into the database and then reading it back in a different program. Okay, and then came Oracle 8. Oracle 8 didn't do much. I don't think I even ever worked with it. In Oracle AI, we got 2 new types of collections. One was the V-array, a varying array, and one was the nested table. And the biggest difference with the current PL/SQL table, which were now called index by integer tables, is that the nested table and the V-array can also be used in the SQL layer, so they can be stored in the table. How do you create a nested table? Well, the syntax looks pretty much the same, except that we don't have the index by binary integer anymore, which you can see here. So if you don't see the index by binary integer, then you have a nested table. And another difference between the index by integer tables and the nested tables is that you have to initialize the collection. You have to initialize it. You have to extend the collection. In this case, I extend it to 5. So I have 5. I can put in 5 items in the collection. Whereas in the index by integer table, we can just put in anything anywhere we want it. Here we have to initialize it. We have to extend, make room for 5 items, and then we can just fill them up. Only those 5 items. And after that, we can use the for loop, since it's a dense collection. Another good thing introduced in Oracle AI was the option to use a bulk collect. We open the cursor and we fetch, bulk collecting all the rows in one go into our index by integer table. So instead of going back and forth for every row, which was also was called row by row or slow by slow, we would now fetch all the names in a single pass to the SQL engine. And since it's always densely filled, always starting at 1, we can use a for loop like this, starting at 1 and go to the count items in the table. Okay, if you bulk collect anything into your collection, remember you're using up memory. And if you're the only one on your database, like on your trial database or on your personal cloud database, that wouldn't be too much of a problem. But chances are there are more people using your code. So be aware of memory issues. Luckily, Oracle also helps us with that, and it gives me the limit clause. And that means you can bulk collect, you can still collect the data in batches of a lot of records, but you can limit it. In this case, I'm limited it into batches of 4, but usually you would limit something like 1,000, maybe 10,000, maybe even 100,000, depending on your memory consumption of your collection. Same cursor, same type, and the only thing is you fetch the cursor, you bulk collect into your collection, and now you limit it by C limit, in this case 4. What you have to do is you have to create an extra loop, because the database will fetch in groups of 4 rows in this case. And it will never, ever give you a no data found or percent not found anymore. So you have to use an exit where you can do exit where when the count is smaller than the limit, or maybe if it's not equal to the limit, or you have to provide your own exit method there. If you want to select more than one column, you can do that by creating a different, in this case, index by integer tables. You can select the different columns, and then you have a lot of variables for all the different types. And if you then open the cursor, you fetch, it will collect into the 4 different variables as we are just querying 4 columns. Not too much of a problem, because this is a very simple example. But what if you have like a 40, 50, maybe even bigger set of columns you want to collect? Something that changes in Oracle 9i. It would mean defining a lot of types and a lot of variables. That was the wrong button. Also in Oracle 8i, we can create a table function, and it's called a function which returns something like a table. You create a nested table in the database, in the SQL layer, and then you can create a package where the functions will return the nested table type. And then in the package, you'll just create the nested table, you extend it by 2, you put in 2 items, and then return the entire set back to the calling SQL statement. And for the relatives, it's kind of an arbitrary example, but you select something, put it into the nested table, and then return that. And then in SQL, you can select the column value. Column value is the only value available from, and then table cast the function daughters as the nested table type. And that's how you can select data from the function in a SQL statement. Oracle 9i. In 9i, we got an extra thing. The index by integer were now renamed again to associative arrays. And the new thing was we can get a index by varchars. So we can index, instead of by numbers, you can index by varchars. So in this case, we'll just put in some names or the text for numbers. It also keeps the ordering, like the ordering in the numbers thing. In this case, it's retaining its ordering, but this time it's alphabetically. And since there is no way you can create a loop on an array of varchars, you have to do the of which I displayed first, go to the first and jump over everything. If there's nothing there, go to the next, and then if the next one is nil, then stop the loop. remember when we selected multiple columns from the table, and we had to create multiple collections and multiple variables. In 9i, we can also create a table of a row type, in this case, based on the table. And then in the cursor, we can just select everything, all the columns, and then in a single statement, we can fetch with bulk collect into the collection of records. So instead of the multiple collections, we bulk collect into the collection of records. 9i also gave us something new in the table functions. We can now make them pipelined. And the biggest difference is that as soon as in Oracle 8i, when the collection was built, and when the collection was complete, it was sent back to the SQL engine. What we can now do is we can create a row, and then as soon as the row is done, in this case just a simple varchar, we can pipe the row out to the calling statement. And so the calling statement can go and do stuff with the row that's there whilst the function is still working. You can use this, for instance, for when you're doing parallelization. And at the end, all you have to do is return control. So it's a single return. We don't return any variable anymore because there's nothing there anymore. What's also good was we can now just do select from table and then the function instead of casting it, etc., etc. Oracle 9i. Let's create a very big table, FAT.dot. It holds 10,000 times the rows in the netmc.dot table. And if I then do something on this table, I'll do a very important thing, making the LID equals the rec ID. If I execute that, it takes me about 4.5 seconds. If I use the same data, but I create a bit of a different, bit more code, I create a PLS integer based associative array, and I fetch all the rows, bulk collecting, limiting 10,000 rows at a time. If I execute that, this does exactly the same as the one before, only this executes in 1.2 seconds. Same thing we execute on 10G, create the big table again, do the very important stuff. And if we execute this, it takes about 0.7 seconds. Of course, Oracle 10 is a lot faster, a lot better. Maybe the database wasn't as busy at the moment I checked this. But if I run the optimized code, which was on 9i, there was a different, this was about 33% of the time needed for the for loop. This one is 0.5 against 0.7, so that's not a very big difference. What happens is Oracle takes your cursor for loop and sort of creates a loop with the bulk collect, something like this, probably far more advanced, but something like this. As soon as Oracle can guarantee that it'll work the same, it'll optimize it into something with the bulk collect. So yeah, that's very good. This is something, let's see. Don't think this, no. In 10G, we create a nested table inside the package. So instead of an object type in the database, we can create it inside the package. And then we do pretty much the same, creating a pipeline table function, and we can still select from the table, from the function using the table operator. How am I doing for time? It is going to be fast. Okay, Oracle 11 didn't do too much. Nothing really new, some speed improvements, but probably Oracle has its own usage expanded, but there's no new syntax. In Oracle 11, what I was trying to do is create a package with a nested table in it, and then try to use that inside the query inside a block of PL SQL, and that wasn't possible. What I had to do is create a type in the database to make this possible. In Oracle 12, I can create a nested table inside the package and then use that inside an Oracle or inside a query inside a PL SQL block. And the good thing is I can even use an associative array in the package as soon as it's being called inside PL SQL. I cannot use the associative array in plain SQL. So it's pretty good news because you don't have to do as much work as you would do with an associative array. Okay, and Oracle 18c, what we got was, now remember in 7, we had to create the collection like this. We had to fill it up, names, and then put in all the items there. In Oracle 18c, come on, go. We got the qualified expressions. So we can create a variable using the associative array constructor, put in something at 1, put in something at 42, 10, etc. If you use the names.count plus 1, which resulted in 4 in the previous one, this time it will result in 1 because names.count is empty at the is 0 at the execution of this statement. So holy will override holy. If you want to go even further, and if you have a nested or an associative array of records, you can use the qualified expression for the associative array, but also for the records within it. And that's a lot nicer. Again, Oracle 19 didn't do too much new work, mainly probably because it's a long-term service release. Oracle 20 didn't happen, and Oracle 21, this is how we did it in, how we created a collection in Oracle 7. That is my alarm. I got 1 more minute. In Oracle 21, we can now loop over this collection. We can now use a for loop for index. In indices, this uses the indices of the collection. So 1, 42, 10, 4, and -1, starting at -1, of course. We can also go running over the values So it'll just give me the values of the collection. In this case, Haley, Hooli, Holy, Hilder, Hattie. So it'll give this in alphabetical order. And then something which was really fun. I didn't really understand what's going on, but I think I get it now. We can go for the index and the value in the pairs. So index, value, and it'll just display those as well. I have to play with this a little bit more. So that was quick. Like I said, inspired by the Dr. Seuss movie, Horton Hears a Who. If you want to have more information on collections, go to these links. I'll get the PDF out as soon as possible. Some info on initializing records and arrays. Of course, Oracle Base has probably one of the best blogs on everything Oracle. And all the scripts I displayed are available on LiveSQL. Search for collections, maybe put in my name, etc. These are my contact details again. And that's it. And do I have any second? No, I'm 1 minute over time. Do I have any questions?
No problem. And there is one question. Oh, no, not a question. It is a thank you.
Okay. Well, very welcome.
So maybe there are other questions, or if you want, there is a special break now. It's a relax break. You can change to the stream 1 if you would like to join this relax session.
There's one more question. Will there be a table indexed by date? No. Not for as far as I know. But you can also always cast a date into a varchar, so you can probably play with that. And that's it. Thank you.
Thanks a lot for the presentation.
You're welcome.
So enjoy your break and be back in 15 minutes.